pointer event manager, and I think I'm going to kind of put it aside for a minute and sort of just do a little exploration with how we want to pick up the mouse events. Originally I was thinking that this would be picking up the mouse events, and then we'd have some subscriptions to some area on the screen, and you would be able to index them and pick them out under the 2D renderer. It seems really, really complex, but I like the way it's self-contained, but I'm going to try something different. So we can look at here, we've got the stuff we've been working with, and I'm going to add the input, so here are the tests. Game loop view port tracker. Some stuff in here that should be saved here. We got interactive display, pointer event. I think one thing I do want to save is get diff test game entities game loop. Really? So we're just going to stash all this. And I kind of want to just sort of play around with how we want to do the rendering here. So I'm going to take out the, just kind of close these out. So the idea I'm thinking is actually doing the mousing here. And it's kind of it kind of couples it to it, but it does make it severely more efficient and easier to work with. So this is easier, but coupled the other easier and faster, but coupled the other way is slower, more complex, but isolated. But I think in this case, we're just going to visit it and see what we can come up with. So first thing we're going to do is we're going to actually just do mouse input get 0, and we're going to say, let's see here, we need to notify. So this is going to be on down, I'm going to say on up, on move, and actually we may not even need, on wheel. Interestingly, let's see here, what's on wheel do? It's on wheel do, okay, wheel listener. So the wheel, I guess we do want to know who's picking up on that, so I'm going to just put right here, right after, say prf on down, say button int x int y int. So there's that one. Actually just need to duplicate that for the next couple. Yeah. And so we have on up, on move, and maybe we don't even need this. I'm thinking all we might need is just the wheel. And yeah, let's try this. Let's take these out. So null, null. Just need the on move. Just sort of thinking through this here. So we just have our move. I don't think we need a button on this one, so I think, look, oops, here, move listener, it does take 4 arguments. I'm not sure why. I think it's actually screen X and screen Y maybe. So let's let's trace this out and see what's going on here. So we've got X, Y. I think actually it's the differences. Let's just put dots there, and we're going to do correct usage of the language, and screen Y. Spelled it wrong twice. So here, let's see which one is which. Let's do a build, run. Okay, and just for good measure, I just want to run our tests. Okay, so we can't run our tests because we're using some cost stuff, which we can isolate if we need to. And here we go, we're building. And so what I want to do is, I think I want to gather up all items under point. So what we're going to do is say private var items, say like, actually, so if we look here, yeah, so the second set of numbers is our difference. First set is where we are on the screen. So if we run around, it doesn't really move. Right, run, it's only relative to the screen. In fact, it actually goes into the negatives, which is pretty cool, and this goes into the severe positives. So we can actually detect when they actually leave the screen, which is pretty cool. So don't really need the difference, so we're just going to take that away. And so say nodes under point, there's going to be an array of display nodes. And so here we don't actually need the screen x, sorry, the diff x and diff y. So this is going to be, man, I think this is going to be a lot easier. So now what we're going to do is whenever we get the event, we're going to say private var current point, current mouse point, I guess. And then we're going to current mouse point equals new point. We're just going to update that. And current mouse point dot x equals x and y. And those will stay there, so we can always have those. And then we'll get our nodes under point equals that. And what we'll do is whenever we move, this will reset. So for, let's see here, I think there's a while nodes under point dot length is greater than 0. Nodes under point remove. Let's see here. We're going to be doing a lot of manipulation. I wonder if it's faster to use a list. So I'm going to say new list. Nodes under point. And we're going to clear it. So that'll be much faster. There we go. So now we'll clear out the nodes under the point, and then we render the children. So what we're going to do is once we get to here, actually technically here, we're going to memorize where we are, actually probably here as well. So maybe the first thing or last thing, probably last thing. No, first thing, because this is recursive. So now we're going to say private function store items under mouse. Okay. Store item. And we're going to have a node. We can call it a display node. display node void. Okay, we can inline this, so it'll be fast, and we'll say if display node is under mouse display node, we're going to store it. So here I'm going to say private inline function is under mouse display node, and it's just going to be a bool. Fast as possible. We need this as fast as possible. If so, I'm going to return the effectively what a rectangle does. And I know it's a little bit duplicated, but we need to make this as fast as possible. And so we're going to do this. And so we're going to say display node.x y height, all that stuff. Okay. Now I'm going to do. Oops. I'm going to grab the current mouse point and extract that. In fact, I wonder if we're going to just do this slightly faster and say private var current mouse x is an int, and this is current mouse y. Okay. Current mouse x, mouse y. Okay. I don't need this anymore. And so, oops, we do need this one now. We need the point. Okay. So that's slightly faster overall. And current mouse x, current mouse y, mouse y. Oops. And there we go. So if it's under the mouse, we're going to do the nodes under point. And I wonder if we could do push. Now if we push, it goes onto the end. Display node, okay? Now, if we want to do that, that means we're working from the bottom up. So maybe we want to do an add. Add. That's better. Okay, so now what we can do is, just for fun, we're going to say on up. PRF on up. This is way simpler. So the button, int x, int y, int. And this is pretty cool. I'm actually really happy about this. So I'm going to say trace items under mouse. And what we're going to do is we're just going to do for node and nodes under point, trace and trace nodes under point, oops, node dot x, let's do this. And node.y, which may not actually be much, but what we can do is we can actually play with this a little bit tighter too. So Let's run this. Player manager. Do we actually set the names? Add layer by name. We actually do container by name equals layer name for fun. We run around. No items under mouse. So that's not what I expected. So let's go back to change this to node.name. And seems to be that we didn't even call it. Okay. So now I think the problem here is we need to do it we need to add it at different points. Like here. It's interesting. The sprite actually does not actually rendered, because it wouldn't be. So really we need this information here and to add it. So we need to is under mouse. We don't want to do display node. We need to send the x int y int width int height int. And so call bitmap node. And this actually has not much to do with Ka now, so we could probably rip this out. But anyways, so the width and height are not pushed up to the two-dimensional display node. Oh, there it is. Yeah, it is. So what we can do, I'm going to do that, is we can call this var x float. Maybe this would be a float. So we're going to do here. So one thing we don't have is the cost sprite. Its width and height needs to be set by the children. So we've got some things to solve here. So if we do this, let's just do this for now. Y. And this is going to be SX. So SW and SH. Width is this. Width and then height. Okay, so height. So that shouldn't change anything. But our text field node also doesn't know anything about its width and height. And so that could be something we may need to solve. So lastly, we need to notify the parent that it's, I wonder if there's any no container. So the width and height does not take an effect of its children. So I'm going to say if is under mouse x, y, width, height, store item under mouse bitmap. Like that. So let's just look at that for now. So I like the idea of this. There's just some missing data here. Here's our hero. If we click here, still no items under the mouse. And that's actually kind of strange. So what we're going to do is we're going to trace x, y, width, height. Let's see what's going on here. float should be int 972. Okay, so float. I didn't even build, so that was an oversight. Here we go. So this actually might work better. So we do need to solve how we want to do our cost sprite and how it actually figures out the children's widths and heights. So it's hard to tell at this point, but these numbers look horribly bad. So 4096 by 4096. Oh, that's the cat. Okay, so take that out. It's picking up on our terrain, which is correct. Should pick up our terrain. But one thing I want to add, so it's getting all the bitmaps, but we're not getting our containers. Maybe that's okay. It's hard to say. So most things are at 0, 0. That seems a little strange. Oh, that's interesting. So what we need to do is that's kind of a bummer. So what we can do is is dirty. Boolean equals false. So here, say is dirty is equal to true. Or no, that's not gonna work. So if dirty is equal true, that means we're going to is dirty and then is dirty false. That way we only need to store it when the mouse moves. Sort of a performance thing there. So if this returns false, you check it. You should need to check all these things. these are regular man. And there we go, those are items for our mouse. So there's 2 of them there. That's just the cat. So you just go around to see these. His location's always going to be the same because he's right in the other screen. But there he is. And that's his actual location that's given to me by the display node. So we can actually figure out his holistic location from his parents. It's not too hard. You can see it does veer a little bit. Is it? No. And now we can click over here, nothing. So that's good. We have the items under the point. Trying to decide one thing we don't know for sure. Let's look here at the Cogtech API is the graphics drawstring. I don't think there's any way to know 2D graphics. We don't really have a way of knowing the width of the string of the on the screen. So that's kind of made things a little tricky. So what we can do is we can force it to have a width and height. I think more likely the case is we do need to know the width and height though. You can make some weird assumptions, but overall they're going to be wrong. Which is kind of a bummer. So it looks like we'll need a way to know that. Anyways, so we do want to do the parent. We're going to need to know their width and height. We could just do this for here. This is child X, child Y. We don't know the width per se. It's going to be width and height. This isn't fully correct, so I've got to change this back. And this is going to be bitmap width and bitmap height. So here, when we get the child, it's not really a child, but window children. And when we get the height and width, we're going to need to get all of its subsequent children and figure out its width and height. The downside, it's such a bummer. There's a huge downside. So if we look at this cost spike, the downside is if we traverse all the children to figure out the width and height, this happens on every frame. And it's going to be like this recursive call of all the nested children, which is pretty heavy. Especially the fact that we're traversing it already. So we need an efficient way to grab the width and height and set it. This is not a return type. So render children could return the rectangle of its extents. And say, if we add it here, I would say whenever it calls the render children, we need to know the extents. Darn, this is a hard problem to solve right here. So I'm going to ignore it for now. So we do have our items under point. No, we can't really ignore it just because of actually, can we? It seems like we'd want to know width and height. Let's continue on. So it's really interesting to note that this could happen. So let's just do this. We're going to grab this. And we're going to grab this. I need that. And it's going to be X. This is going to be Y. And this is going to be the child width and height. So it'll be in there when we're ready. Now what we need to do is we can drop the mouse down or move. The hard part is we need to know which one it's called first. could put the handlers here in this class and pass it down to the hard part about this is that this move, we don't know when the move is going to happen. So what we're going to do is when we say if is dirty, trace move render, and this is going to be trace mouse moved. So we actually don't know the order in which these will happen. If this happens first, we need it to. So that kind of gets into a tricky situation that we need to actually call render. Which now we're getting double rendering going on, so that's not that great either. So did I miss something? Line 68, 69. Child. Okay. So mouse moved happens first, and then the render is called. Okay. So that in that case, if is dirty, we would actually call the like the pointer handler or whatever, mouse move, right? In the every other case, we would call this on up or on down. So that'll work. So this will work. In fact, I'm not sure if we'll even need these other events here like I thought. We just need mouse moved. But may as well just pass them all down so it's not like something that's partially handled in two places. So what we're going to do is, if I just do that, and we're going to say, we can call that pretty good. It's a good experiment. We have a couple of things to solve, which is parents. And I think right now it's breadth first, or depth first, so it would actually see the containers that everything falls below, or falls inside of. Okay, so we need to input. So I wonder if we can just do git stash pop. And so we get some of our stuff back. We get interactive display. And we've got the two-dimensional interactive display. Not sure if we need that. Yeah, we do. Got our renderer. this is not fully correct anymore. We've got this, the mouse input source. This is going to be something we need to extract and pass this down to it. Space object. So we need to change this quite a bit. That's okay. So now we also have our pointer event manager. So it registers the event on a display. So that all still makes sense. We don't need the update display location anymore. And so pointer event manager. We don't need this anymore. And it doesn't necessarily need to be CA anymore. This could be our pointer event manager. And so what this will receive are all the items under the point, and then we can actually locate the items. Don't even need to index it anymore. We can just traverse the tree, find out where what has been clicked, and that's it. So let's take some of this out. We don't need that. We don't need this either. So we do need all their subscribers, because those are listening for our events. And so let's run our tests. I think our tests won't actually run still. So if we go back here to our 2D renderer, we're going to need to do like if this is CA, if test. So that'll do that for now, and then we can take input mouse here, input mouse. And pointer manager line 20. Don't need that anymore, don't need this anymore. And the test 108. And we don't even need this anymore. Yeah, we've cleaned up a ton of stuff now. CA 2D renderer is our last point of thing. So what we need is our pointer event manager. And I believe this is where our two-dimensional display actually talks to the event manager directly. So we need to make one more layer above that, which is a input source handler. And that should have been an interface. And so this extends base object of always. And what this we could do is we can say like function handle mouse move, and we give it the objects. And this is be a list of display node. And then we probably should do the mouse x int in the mouse y int. So there. And this would be a void. And we can do handle mouse down, mouse up. And actually what we're going to need to know also is our button. And we also need to do handle mouse wheel. And that is, I believe that's just 2 arguments. So now we're making some really happy things going on here. Happy world. So this is going to be the Ka render. And we're going to go here to notify, and it's going to be int. Yeah, that's what I thought. So says that. So these are all these things, and those will be passed down to those. So it's your input source handler. This is going to be just delta int. Okay, so we have mouse wheel, mouse move, up, down. Okay, I think that's all we need on the highest level. So that gets passed down to input source listener, which is going to be passed down to probably our pointing input source listener. What we could do, so this is actually specific to our world. That's this stuff. And this gets passed down to the current tool. So there's some neat little magic going on here that we need to rationalize. Ka input mouse source. Basically what this is going to do, this is going to listen to one of our containers and get these same type of events. So it's not out of the loop yet, but it is on the chopping block. All right, so input source handlers, we have the mouse move, down, up, wheel. Okay. What we need to do is probably call it a day, but I'm happy with what we got going on here. This definitely needs to be tested over here. Why does this have changes? Oh, that has a very good change. Okay, so just reviewing what we have. So what we can do is we can set up the methods to call. And that'll do it. So we're not working right now, so we need to, it's called the import source handler. So we're going to inject input source handler, and it's actually specifically to a mouse. Mouse input handler, and that's actually not really accurate either. We need to probably call it like mouse display input handler. So it's like it's not fully correct either. The naming on this is tough because it is only specific to mouse events or pointing events, and it's getting the display nodes too. So I guess we'll call it mouse input. What I'm worried about is like it looks like this is the display of the mouse, which could be a thing. We could change the mouse cursor, so we don't want to do that. And we don't want to just say display mouse input. That doesn't sound right either. Maybe it's display event mouse input handler. That seems close enough. And so now here we say mouse. We just call it input handler. And this will be handle. We don't want to do handle. Mouse move. Mouse down. Mouse up. Mouse wheel. And this is going to be mouse move. The nodes would be nodes under a point, and we're going to need the button, which doesn't make sense for mouse move. So it's just going to be mouse move doesn't have a button. And we'll do, is it the current, oops, current mouse X, current mouse Y. There we go. So that's great. We're on the right track. So that should still build. And hopefully still pass. Yep, everything's still passing. Our test coverage is down because of our CAD 2D renderer. And so that's that. Alright, so what we're going to do is git status, git commit, left out our display event class events. Okay, so we're going to just push that to master. Let's push it to the correct master. How about that? That sounds cool. And anything else? Need to do, we'll state this here. Kit tag 2016 08 57 at, actually that's not right, 08 18 08 58 now. Git push Skylar this. Alright, we are up on the server, and that's it. So we got a bit covered here. I'm going to continue on tomorrow. Happy coding. See you guys then.